Hello everyone, welcome to our mathematics channel 360 degree mathematics. In the last videos we discussed different problems of permutations and different types of permutations, and in today's video we will discuss a special type of permutation, that is circular permutation. Circular permutation is to some extent different from linear permutation. Now we are starting circular permutation. That is circular permutation. The simple understanding is that permutation will be adjusted with respect to circular fashion, and first we establish here the formula and then we prove the formula, how this formula comes. The number of circular permutations of n different objects is n minus 1 factorial, and we will again establish by proving this formula. Suppose the term circular we consider here in this way or in this way. Both are circle, and we can start from here. This is A1, this is A2, this is A3, this is A4, and so on. This is AN, and the previous is AN minus 1. Again it can be shown A1 left side, A2, A3, A4, and order. This is AN minus 1 and this is AN. Whatever it may be, whatever may be the direction, that is clockwise or anticlockwise, we don't consider now. Now we will simply focus on circular permutation. Proof: let A1, A2, A3, A4 AN be n different distinct objects. Let the total number of circular permutation be x. We get x number of total circular permutations. We considering one of these x permutations as shown in the above figure. Whatever may be the direction, we have drawn a circular fashion to set A1, A2, A3, A4 and AN. Now clearly this circular permutation This circular permutation provides in linear permutations. In our discussion at the first step, I mentioned that there is a subtle difference between linear and circular permutation, but there is similarity also there. Linear permutation as A1, A2, A3, An minus 1, An. This is starting from A1. But whenever we are starting from A2, then it becomes, and the last part is A1, circular permutation. Similarly, whenever we start from A3, A4, A5 and so on, An minus 1, An, A1, and it ends at A2 and so on. In this way, we can set An, A1, A2, A3 and so on. Last part will be An minus 1. All these are linear permutations, starting from one part and ends in another part. Now each circular permutation gives n linear permutations. Now each circular permutations provides n linear permutations. In our discussion, firstly, we considered x number of circular permutation, but we considered x number of circular permutations. Therefore, we can mention that number of linear permutation is xn. Now, number of linear permutations is x into n. But the number of linear permutations of n different objects. But we know that number of linear permutations of n different objects is n factorial. This is our basic rule. Now by structure, hence by structure we can write x n equals to n factorial. It implies x equals to n factorial by n equals to n into n minus 1 factorial by n, and it becomes n minus 1 factorial. Therefore, number of circular permutations is n minus 1 factorial. This is the answer. Now our proof is complete. this marks star marks, that is important. Difference between clockwise and anti-clockwise arrangements. Anti-clockwise arrangement. Suppose this one and this one, A1, A2, A3, A4. Here we move from A1 to A2, A2, A3, A3, A4 and again A4 to A1. This is anti-clockwise. Anti-clockwise. And in another style, A1, A2, A3 and A4. This is clockwise. First, we have shown anti-clockwise, that is in this manner A1, A2, A3, A4, and this is clockwise A1, A2, A3, A4 clockwise. Number of circular permutation in clockwise and anti-clockwise. Number of circular permutations of n objects in which clockwise and anti-clockwise arrangement provides different permutations, is, that is different permutations. Mind it, different permutation means whether we consider clockwise or anti-clockwise, then we get more permutations, that is n minus 1 factorial. N minus 1 factorial. But if anti-clockwise and clockwise orders of arrangements are not distinct, or distinguished, then the number of circular permutation becomes of n items becomes half into n minus 1 factorial. And this formula focus is for arrangements of beads in a necklace flowers in a garland, etc. Actually, the concept implies whether it will be considered as anti-clockwise or not distinguished. These two formulas have been established now, and now we will focus on some problems. Now the question number 1 is, in how many ways can 7 students form a ring? Total number of students equals to 7. Since they form a ring, therefore we will focus on circular permutation. Hence we use n-1 factorial ways, that is 7 minus 1 factorial equal to 6 factorial equal to 720 ways. The answer is complete, that in how many ways can 7 students form a ring, that is in 720 ways they can form a ring. Question number 2, and this is plain n-1 factorial formula. In question number 2, in how many ways can 7 beads of different colors be arranged to form a necklace? Here the word necklace implies our second formula, that is half n-1 factorial. Since 7 beads of different colors be arranged in a circle relative to themselves, so they can be arranged in 7 minus 1 factorial, that is 6 factorial. Hence, for necklace, clockwise and anti-clockwise are not distinguished. Therefore, required number of arrangements will be half n minus 1 factorial, that is half into 720, that is 360. This is our answer. This is question number 3. This is to some extent theoretical question. The number, find the number of ways in which n things of which are alike. Find the number of ways in which n things of which are alike can be arranged. In a circular order, in a circular fashion. Its solution is very simple. That is, technically it is, let the required number of arrangements be x. Consider any one of these x arrangements. Considering any one of these arrangements, consider any one of these arrangements, of these x arrangements, number of total permutations is x arrangements, we get R number alike. These R things can be arranged. Among themselves in R factorial ways. Hence, X arrangement will give X into R factorial arrangements. But if we, here is our alike arrangements, but if all the n things are different, then the number of circular arrangements equals to n minus 1 factorial. by condition we can write x into r factorial equals to n minus 1 factorial. Hence x equals to n minus 1 factorial by r factorial. This is our required answer. The answer is complete. Today we discuss only circular permutations and place 3 types of problems on circular permutations. In the next video we will discuss both type permutation problems, and in that next to next video we will discuss competitive level problems for permutations chapter. And this is our completion of today's permutation analysis. This is all about today. Please keep watching to our channel for new updates, new videos, and thank you all for watching this video.